Okay, so I think we can switch to English and get started. As I told you, today our main topic will be testing. Yesterday we started a little bit with our first tests regarding the TicTacToe exercise. And the last thing that I asked you to do yesterday is to create these final 3 tests. Oh, we have a visitor. So the last thing that I asked you to do yesterday is to create these 3 tests. I'm pretty sure you can remember. I asked you to build tests where the winner identification is tested automatically. Now let's take a quick look at a sample implementation that I did. Let me see, I will just copy it from my GitHub repository. You implemented it hopefully yesterday yourself. If not, you can take a look at my GitHub sample solution here. And let's quickly take a look at these tests. We have one that says detect winner in row. And what I typically do, I try to be very specific in the test data. Especially in such test cases, it always makes sense, at least if you ask me, to add some comments or at least some kind of very clear variable names or so on to specify the test data that you want to build. For instance, in my case, I have drawn here the tic-tac-toe board that I would like to set up in order to detect whether the winner detection is correct. So this is kind of interesting or kind of important. This is what I wanted to say. When you are going to write a test, when you are up to write the test, always be very clear in what you are going to test. I've seen many developers who start to write tests without thinking about it. In your mind, you have to have a very clear picture. What should that test do and what should that test verify? Otherwise, you will end up with a single test where you do 50 different things and you check I don't know how many things and you end up with spaghetti code in your testing environment. So please be very clear. Every test should have one purpose. And you have to be very clear about what this purpose is. And in that case, we say detect winner in row. We build the following board and then we verify that player 1 is the winner. So it is for somebody who reads this code, it is very obvious what this test is going to be. Second is kind of clear, same concept. Third is kind of clear, same concept. Last but not least, I added a final test and I ask you to also add this test. You can either copy it from my GitHub repository or you can simply type in these few lines. I give you a second. This test contains some, let's call them MapReduce functions where I'm not 100% sure whether you know about them in JavaScript and TypeScript. So I would like to spend a few moments on them to tell you about them. So please, it's kind of clear what this test does, right? Clears the board on restart correctly. So it resets all the cells to empty. Are you familiar in JavaScript and TypeScript with methods like this, like filter and map and so on? Okay, but in other languages? In Java, how is this kind of programming called in Java? Stream? Stream API. Okay, I'm not a Java guy, so I really don't know the answer to this question. In C# it would be ling. You have maybe done that in other courses. In Java, as you said, streaming API. And here we have these filter and map and so on. Just to give you a quick overview about the most important one, let's just go into the TypeScript playground. You do not need to follow along. That's just a quick demo so that we make sure that everybody understands that. If you have, for instance, some numbers, something like this, okay, oops. Then one of the easiest functions that you can do is the map function. You can say for const number of numbers map, see? Then you define the number parameter, n will be the current number when we iterate over the numbers. And then we can, for instance, say multiply this guy by 2. Oh, I've done too many C# programming. Then we say console log number, something like this. And if I run this guy, I see 2, 4, 6, 8, 10. It's kind of clear, right? Yeah, so this is the map function that it can use to map or project would be the technical term, to project something, in this case just multiply by 2. Filter is also not very difficult. What you can say is you can say filter, and then, for instance, let's say n modulo 2 equals 0. That will be just the even numbers, and that is 2, 4, no, that's the wrong one. Here, 2 and 4. That's the right one. So this is filter. You can do that with any array that you create, not just array, other data types too, but for our course currently, it's only interesting when we have arrays. Okay, so remember the map function and the filter function. There are more functions like that. You can look it up in the documentation. By the way, do you know the best source for how to find all the members that are available on array, for instance? Where do you typically look for such functions if you would like to find the correct function for your requirement? MDN is the Mozilla Developer Network. MDN has a lot of very interesting courses. Here you see the entry courses into JavaScript and so on, and here you have the reference. You can go to the JavaScript reference, CSS reference, HTML reference. I really love this. And if we, for instance, say, let's look for map, then you see here you have the array prototype map function. And on the left-hand side, you see all the different functions that are available on the array type. Yeah? And this is super, super interesting, very interesting to read. Very good. So we learned something. Let's go back to our Visual Studio Code. Let's see what this thing does. It says filter all cells which are not 0, and then we check whether the length is greater than 0. And then we project the length here, and we require that the length of cells that is not 0 has to be 0. So we check whether all the cells are 0. I can enhance my own code. We can use the sum function, which returns a Boolean if some cell fulfills the given predicate. Sometimes when you write tests, you end up having pretty complicated logic inside of tests. Maybe you have complicated logic to build test data, or maybe you have complicated logic to verify the expectations. Then you have to test the tests. It doesn't make sense to write a very complicated test algorithm and then think that everything is okay if you get a green check. Who says that the complicated test algorithm itself works? So do not forget software engineering principles when you are writing tests. When you are writing tests and you write a complex algorithm, you have to write a test for the test. Believe me, I've written an endless number of tests that went green, but not because the test was successful, but because I screwed up when writing the test. Or the other way around, the test was red, the algorithm that I tested was perfectly fine, but I simply screwed up when writing the test. So if you have complicated, this is not a complicated algorithm, but if you have a really complicated algorithm, building test data with recursive algorithms and things like that, write the test for the generating method that generates the test data to make sure that this is okay. We will probably not run into this situation anytime soon, but for now, it's perfectly fine. Can I assume that this is pretty clear and you understood the basics of these Jasmine unit tests? Good. Then let's try to apply exactly that knowledge and test the pipe. So what I would like to do next is I would like to go into level 5 and write a test for the, let's take this one, for the player into main pipe. How do we do that? We create a new file, player into name pipe spec.ts. They're always called spec.ts. If you take a look down here, then you see that Angular automatically generated 3 different configuration files for TypeScript. Please take a look at my screen. If I take a look at that one, you will see that all the different compiler options that Angular needs or recommends are inside of this tsconfig JSON. But then you have a tsconfig app JSON. And this tsconfig app JSON extends the original JSON and is the definition for compiling the app itself. While if I take a look at the tsconfig spec JSON here, I see this also extends the basic tsconfig file, which contains all the compiler options. But here in the include, you see that we include the spec files. So the spec files are only compiled when we do a test run. When we build our own app, it doesn't matter whether the tests are okay, they are not even compiled. Let me demonstrate that to you. I can stop my Karma here. I can screw up something here. This is definitely wrong. This is not correct TypeScript code. And if I run npm run build, it will still succeed because the spec file is completely ignored when building your app. This is why we can easily delete the spec files or add some. We can simply ignore them as long as we don't run npm test. But we don't ignore our spec files now because we know that they are useful. Let's start with the player into name pipe. Let's quickly recap what we did. Please follow along. We start with a describe. Can you remember? Then we have a kind of title for all the different, for the thing that we are just testing. And in our case, we say this is the player into name pipe. Then we specify a lambda function with all the different tests. That is just a repetition from yesterday. Next, we define the it clause here, and let's call it transforms 1 into x. Let's instantiate the pipe. Yeah, GitHub Copilot did it nearly correctly. And I have to say player into name pipe. Don't forget to add the import automatically. Visual Studio Code will add the import automatically. This test is trivial, but the point that I want to make is a different one. So for now, bear with me, please. Can you guess what the next test will be? We simply take this test here, duplicate it, and say transforms 2 into O. Transform 2 into O. And while you're typing it in, I'm also saying npm test to spin up Karma and to run the tests in my browser. You can do that in the background yourself too. And I'm happy because we have everything green. Please note that the name of the describe ends up as the name of the section of all the tests which relate to this thing. So player into name pipe is a kind of heading for all the tests that relate to player into name pipe. Now comes the thing that I wanted to make very clear. Don't forget that this is a regular TypeScript function. So if you want to have a single pipe and use this pipe throughout all your tests, that's absolutely no problem. Let me show what I mean. I can take this instance of the pipe and simply move it outside of the it. See? And then I can remove the second pipe. I don't need it anymore. So you can, without any problems, write some initialization code that relates to all the tests inside of this describe section on top of these it statements. In this case, it's perfectly fine because these tests don't have any side effects. They don't manipulate any properties. They don't store something to a database or whatever. They are pure functions. So it's an enhancement in terms of efficiency to create the pipe once and use it in both tests. We are going to need that in the next test after the pipes when we try to test an Angular component. Let's add the third test. It throws on invalid player ID. What does throws mean in that regard? Let me show you the original code. See? Just to refresh your memory, what we implemented is if the player is lower 0 or greater 2, we say invalid player. And this is exactly what we want to test. And the thing that I would like you to take away from this example is that it is important to not just write code for the happy path, where everything is okay, but also write code for edge cases that lead to errors. In this case, we say expect Then the lambda function, pipe transform, 3 in this case, 3 doesn't work, to throw. To make sure that this throws an error. Optionally, you do not need to do that absolutely. I just want to make it very clear so that you understand it. I can say describe happy path. So I can structure my tests further. I will put these 2 tests in my happy path, and then I will say describe sad path. No, error cases. And I can move these lines up here, and then I have a better structure in my test case. This is just optional. If you have pretty long test suites, then it might make sense to structure them into multiple describe sections, because then you can also fold these describe sections. You have a nice overview what the tests are all about, and then you can dive into the details if you are interested in. And if I take a look at the output, it really structures the output in a nice way that is easy to read and easy to navigate. In real life, you have hundreds, if not thousands, of unit tests for a non-trivial Angular application. So structuring the tests accordingly is a really important task. It's not super complicated, but it's important. The difficult thing in real life is to write the required testing code, because in real life, the testing is not as trivial as you can see it here, in many cases. It's much more complicated. But hey, we have to start somewhere, and this is okay to get started. Does everybody have green tests? All the green tests? Very good. So let's practice it again. To close our pipe testing, just for the sake of completeness, we will also write tests for the player name into class. And this is really, really simple. Remember what we did? We passed in the player and we made occupied something from it. So the test will not be very complicated. Still, I would like to do it. So what we are going to do, let's create a new file, player name into class pipe spec ts. Let's practice it again. Let's do a describe. Player name into class. Let's create the pipe. Player name into class pipe. And write our 2 tests. It transforms x into occupied x. Expect pipe transform to be occupied x. And for the sake of completeness and that we are done, we do the same for O, because these are the 2 very important cases that our application always needs to be able to handle. And therefore, we test exactly that. Quick check. Are we green? Yes, we are green. Player name into class. We already have a bunch of tests. It kind of feels good to have these tests in place, doesn't it? I like it. I don't want to stop coding until I get my green tests. This is my computer saying, hey, Rainer, you did good. Your code works. I'm happy with you. It's kind of satisfying, really. This is the mindset where I would like you to be in when you write code for your 2-year project, or when you write code for your final year thesis. This is the mindset that I want you to be in. When you write code, you're only satisfied if you have also written a test that is green. I've seen so many projects, not just from students, where people write code on a, I don't know, Friday afternoon, and then they leave for a long weekend, and their colleagues are left with broken code because on Friday afternoon you simply screwed up and you wrote the wrong algorithm. And then your colleagues are mad at you. And we don't want to have that. If you have unit tests, if you have integration tests, you have a kind of safety net that ensures that your colleagues will not be mad at you, because your computer will give you immediate feedback that what you did isn't wrong, isn't completely wrong at least. But one final thought here, before we go into testing of components. Automated testing will never make manual testing obsolete. That does not happen. You have to test your application manually too. You have to start your app, you have to click around, you have to check whether it works. Again, I have seen an endless number of cases where developers screwed up and then their colleagues were mad at him or her and say, hey, what did you do? Your code is broken. And the response is, no, my tests are green. Yes, but then your tests are broken too. It is really important to also run the apps manually and test it. It sounds obvious, right? But people don't do it sometimes. I've seen people walk into really important presentations without ever trying their application. Why? They have so many and so good tests. But at the end of the day, the only thing that is relevant for your customer and user is a working software. Whether your tests work or not, is your customer really, I don't want to use bad words here. They don't care. They only care for the user interface doing what they intended it to do and not about your tests. So tests are important for you, but it doesn't replace manual testing. By the way, in a real-life project, who do you think writes tests? Who do you think writes tests like that? Will the developer who wrote the logic write the test, or will a different person write the test? What do you think? Okay, I'm looking forward to your 2-year projects and your final year thesis. I'm really looking forward to that. Because if you write if you write an algorithm, I'm really looking forward to you asking your colleagues, who would like to write some test for me? Do you think you get a lot of volunteers for that? Probably not. So in theory, it would be ideal to have a team where the tests are written by somebody else. That is a kind of development that is, in theory, really good. Because then somebody else has to take a look at your code, has to understand your code, has to understand the requirements, has to come up with some tests. The requirements have to be clear. In practice, this rarely happens. In practice, you will have to write your own unit tests. Other people will maybe write end-to-end tests, the thing that we are going to take a look at when we use Cypress today. So that is often the case, that you have dedicated testers who really automate UI tests. But unit tests are typically in practice written by those people who write the code. So what works for me best is I write the algorithm and the test nearly at the same time. I write the function, and immediately when I wrote the function, I think about, okay, what will be the test? I'm not going to implement the entire application for 2 weeks, let's say, and then spend 2 weeks writing tests for it. That is not how it works for me. But what I do is I try to build, let's say, a meaningful unit of work that does something meaningful, and then I immediately write the test for it. Because then I know where the problems are, where the recursive stuff is, where the complex loops are, where the complex conditions are, and I can write tests as long as I have the algorithm and the structure of the algorithm in my mind. That's a so-called white box test. I know what my algorithm does, and I write tests to make sure that it behaves properly. Some people also talk about test-driven development. Have you heard about this topic? Have you ever tried it? Oh, it's really hard, isn't it? It's super hard. Test-driven development, just to refresh your memory, is about writing tests first. So not writing the algorithm, but writing tests first. If you want to do that, quite naturally, you have to have a very clear picture in your mind what you are going to build. In practice, in many cases, up front, you don't know what you are going to build. You get a requirement, something like, build a small game for me. And that's the requirement. Now do test-driven development. It doesn't work because you don't have clear requirements. Even if you have clear requirements, build a software that enhances the performance of this and that application. And then you are sitting in front of the computer and you think, okay, how can I enhance the performance of this application? Well, let's write a test first, because I have learned that test-driven development is good. What kind of test are you going to write? You don't have an idea what you're going to do. Are you going to enhance the memory management? Are you going to enhance the algorithm? If algorithm, which algorithms? Are you going to enhance the database access or indexes in the database? You don't have any idea what you do. As long as you do not have a clear picture in your mind what you are going to develop, you cannot do test-driven development. Because you can't write a test for something that you don't know is going to happen. It's different when you have bug reports. So for instance, if you have a working software, in our case, we have a TicTacToe, and somebody sends us a bug and says, if I have 3 X's in the middle row, the winner is not correctly detected. Then you can do test-driven development. Then you can say, okay, before I fix the bug, I write a test that fails and simulates putting all the X's in the middle row. Then the test fails. So we did the test before fixing the bug. Then we fix the bug. The test has to go from red to green, and the test remains in our test suite. So we can be sure that this bug will not be reintroduced in our application. In that case, test-driven development really makes sense. Try to think about that when you do your 2-year project and your final year project. Unfortunately, many students do not. I've seen so many diploma theses and so on with not a single unit test. Students tell me that they planned to do tests, but they didn't find the time for it. Exactly that. They wrote the whole project and then they thought at the end we are going to add tests. That will never work. Never. Are we green? I think we are green, right? Yes, everything is green. So let's check. Okay, we are 2 minutes before the break. That was a very good timing. So let's go into the break, and at 8:55 we are going to continue, and our next topic is testing the Angular component. So we are going to test, I think we are going to test level 4 or something. I will think about that during the break. So enjoy the break. We'll be starting again in 5 minutes.